You have probably walked past a building that looked slightly off, a wall that was not quite straight, a floor that sloped just enough to notice, and you probably thought, that is not safe. But here is something nobody tells you. The most visited tower in Europe has been leaning for 800 years. Engineers knew it was falling. They watched it get worse every single decade. And then in 1990, they did something nobody expected. They made it lean more, on purpose. And it has not moved since. Here is exactly how. Before we get into why, you need to feel what we are actually talking about. The Tower of Pisa stands 56 meters tall. It weighs approximately 14,500 metric tons. To put that in perspective, that is roughly the weight of 1,000 fully loaded school buses. Construction began in 1173. It took nearly 200 years to complete, not because of the lean, but because of wars, plague, and political turmoil. The lean actually started during construction itself, before the third floor was even finished. By the time engineers intervened in 1990, the tower was leaning at 5.5 degrees. The top of the tower was displaced 4.5 meters from where it would be if the tower stood perfectly straight. To put that in perspective, the top of the tower was nearly 5 meters out of position on a 56-meter structure, and it was getting worse by 1.2 millimeters every year. Left alone, engineers calculated it would collapse within decades. Here is what most people assume. The tower leans because it was built badly, poor planning, incompetent engineers, a mistake that should have been caught and corrected at the start. That assumption is partially right, but it misses something far more interesting. The soil beneath Pisa is the real story. Pisa sits on the edge of the Arno River Delta. The ground beneath the city is a layered mixture of clay, sand, and silt, deposited over thousands of years by the river. It is soft, it is compressible, and it is not uniform. When construction began in 1173, the builders knew the ground was soft. They built a foundation that was standard for the time. What they could not have known was that the soil on the south side of the tower was slightly softer than the soil on the north side. As the tower grew heavier, it began to press down into the ground. The south side compressed more than the north side. The tower tilted, and once a tall, heavy structure begins to tilt, gravity pulls the center of mass further in the direction of the lean, which compresses the soil even more, which increases the lean, which pulls the center of mass further still. Engineers call this a self-reinforcing cycle. Every millimeter of lean makes the next millimeter more likely. For 800 years, nobody could stop it. But here's the part that genuinely surprises people. The solution the engineers found in 1990 did not involve pushing the tower back. It did not involve straightening it. It did not involve reinforcing the foundation from below. They fixed it by making it lean more first, on purpose. Here is what is actually happening beneath that tower right now. In 1990, a team of engineers led by Professor John Burland of Imperial College London proposed something that most engineers at the time thought was insane. Instead of trying to support the south side, where the lean was happening, they would remove soil from the north side. By carefully extracting small amounts of soil from the north side of the foundation, they would allow the north side to sink very slightly. The tower would tilt back toward vertical, just enough to reduce the lean, not enough to straighten it completely, because straightening it completely would destroy the thing that makes it famous. The target was not a perfectly straight tower. The target was to reduce the lean by half a degree, to bring it back to where it was in 1838, safe, stable, still leaning, but no longer falling. The process took 11 years. Engineers used hollow steel tubes, drilled into the ground at precise angles on the north side. Soil was extracted in tiny controlled amounts, measured in cubic centimeters. The tower moved in increments too small to see with the naked eye, but the instruments measuring it never lied. Millimeter by millimeter, over 11 years, the Tower of Pisa straightened by 45 centimeters. The lean went from 5.5 degrees to 3.99 degrees, and then it stopped moving. And here is where it gets genuinely remarkable, because the same principle that saved the Tower of Pisa is used by engineers around the world. Think about the foundations of large buildings in cities. When a new skyscraper is built next to an existing building, the excavation for the new foundation can remove support from the soil under the existing building. The existing building begins to tilt, sometimes by millimeters, sometimes by more. Engineers monitor this continuously, and they use the same technique, controlled soil extraction on the opposite side, to counteract the movement before it becomes visible. Think about Venice. The entire city is built on wooden piles driven into soft lagoon sediment. For centuries, Venice was sinking. The buildings were tilting. The famous campanile of St. Mark's Square collapsed completely in 1902, with no warning, after standing for nearly 1,000 years. Engineers have spent decades since then monitoring every major structure in the city, using ground sensors and satellite measurements accurate to millimeters, to catch the same kind of slow, self-reinforcing tilt before it reaches the point of no return. Every large structure on Earth is in a constant, slow negotiation with the ground beneath it. The soil pushes back, the water moves through it, the weight above compresses it unevenly, and the structure responds, millimeter by millimeter, over years and decades. The only question is whether engineers are watching closely enough to catch the movement before it becomes catastrophic. Here is what most people never think about when they look at the Tower of Pisa. Galileo Galilei was born in Pisa in 1564. Legend says he used the Leaning Tower to conduct his famous experiments on falling objects, dropping two balls of different weights from the top to prove that gravity accelerates all objects equally regardless of mass. He climbed 294 steps to the top of a tower that was already 1 meter out of position. He studied gravity from a structure that was slowly being defeated by it. The engineers who saved it 400 years later used the same understanding of forces, applied with instruments Galileo could never have imagined, to reverse what gravity had been doing for 8 centuries. Here is the connection that most people never make. The same principle that saved the Tower of Pisa is the reason your house has gutters. When rainwater falls next to a foundation, it does not just sit on the surface. It soaks into the soil. It softens it. It changes how the soil compresses under the weight of the structure above. Over decades, one side of a house can sink slightly more than the other if water consistently pools on that side. Doors begin to stick, floors begin to slope, cracks appear in walls at angles. This is the Tower of Pisa effect, on a domestic scale. Gutters exist to carry water away from foundations, to keep the soil conditions as uniform as possible on all sides of the structure, to prevent the slow, self-reinforcing tilt from ever starting. It is the reason large civil engineering projects spend enormous resources on drainage before a single foundation is poured. It is the reason buildings in earthquake zones are designed with foundations that can flex slightly in all directions, so that if the soil shifts during a tremor, the structure does not experience uneven forces that start a lean. Every structure on Earth is in a negotiation with the ground beneath it. The soil pushes back, the water moves through it, the weight above compresses it unevenly, and the structure responds, millimeter by millimeter, over years and decades. The Tower of Pisa made that negotiation visible. It turned an engineering problem into a landmark. It became famous for its failure and survived because of the precision of its rescue. So the next time you see that photo of someone pretending to hold it up, know that the real people who held it up drilled steel tubes into the ground at precise angles, extracted soil by the cubic centimeter, and spent 11 years moving a 14,500-ton structure by 45 centimeters, not with force, with patience, with measurement, with an understanding of how the ground beneath us behaves when we are not watching. And if the Tower of Pisa surprised you, wait until you find out why the Great Wall of China disappears when you look at it from space, because what you have been told about it is not what the science actually shows. Subscribe so you do not miss it.